In this lesson, we're still working with integrals where, remember, right, integrals are all about finding the area under the curve. And when we talked about area under the curve, so like let's say, for example, when we had area under the curve of, I'll just give like this graph here, but we were also given our boundaries, right? So if I wanted to know what was the area under the curve from 1 to 4 of this function, then what we're doing is we're going from where x is equal to 1 and x was equal to 4, and we are calculating the area under the curve, right? So between my function and the x-axis. That's what we've been focusing on. Now, what about though if we had two functions? Again, continuous functions, so there's no holes or gaps or jumps or anything like that. Still bounded by, right, like 1 to 4 I just showed, so a to b. But what if you had two functions here, like f of x and g of x shown? And again, we're focusing on here. So to find the area between the two curves, because now we have two functions, that means we're going to subtract the f of x minus g of x. So keep in mind when we're talking about f of x, we're talking about the top function. So the top function minus the bottom function. So again, notice how here g of x is going to represent the bottom. And again, a to b, or if you're not given, we're going to focus on the region where they are together. So if you weren't given a to b, we're going to focus on the endpoints here. So just to start with a setup idea, like here we're given the graph, we're given the shaded also. And take note, we're also focusing on the boundary or the graph y is equal to 0 because we're not going into the negative. So here, if we wanted to set up the integral, notice how when we're talking about the x values, we're focusing on from 0 to 9. So we're going from 0 to 9, right? We're focusing on the area between our functions. So that means here we've got our f of x, which is the square root of x here. So we've got the square root of x, then minus, then our g of x, which is x minus 6 dx. So again, here, because we're staying with positive, that's why we also have that boundary. Now, that means we're going to find the integral from 0 to 9 of negative x plus radical x plus 6. So we are finding the integral again with respect to x, but notice having to distribute that negative here. So that's why it's now positive 6. So again, we've got x squared plus 2. Now notice we're just given y, but here's our x squared plus 2. So notice this is our top function. This is our f of x. Then we've got our y is equal to negative x. So notice below, there's our g of x. Also notice the boundaries. We are given the boundaries. So we're talking about from x is equal to 0 to 1. So we're focusing on the area of this entire region. So past the x-axis, because we're talking about between f of x and g of x. So that means here, to set up our integral, we're focusing on from 0 to 1. And again, f of x is the top, so x squared plus 2 minus our g of x, which is negative x. So here to combine, that means we're going to find the integral from 0 to 1 of x squared plus x plus 2 with respect to x. So again, that is our integral. So then here, if we want to take it a step further, right, then go ahead, pause the video, find the integral. And so here we have x to the third divided by 3 plus x squared divided by 2 plus 2x. Then again, right, we're not going to put plus c because we're focusing on from 0 to 1. So then here, that's when we would substitute our value of 1 for x and then subtract after substituting 0, which is actually nice in this case, that would just be 0. So that is in the end what we're calculating here, all right? So let's go ahead and continue, and we're going to do one more. Now, notice here, we've got no setup, we've got no graph. Now, if you're good to go and you remember how you could do a sketch of these, go for it. But if you don't, then we're going to use Desmos Graphing Calculator, because we also need to know the boundaries, right? What x values we're focusing on. So here, I would say pause the video if you need to, set up Desmos, go ahead and graph these two functions. And so here, if you were to graph, and I'll zoom out, notice here's our graph of negative 6 minus x squared, and here's x. So we're going to go ahead and I'll do a quick sketch here of our two graphs. So we've got 6 minus x squared. Now it doesn't go up to 6, so I'll just count by 2. So 2, 4, 6, right? And so here, just doing a little quick sketch. And then our g of x, which is our just slope of 1. So again, because of a quick sketch, if we want to be specific about what our x values are, because now keep in mind, right, we're finding the area between the two curves. We're focusing on here to here. So let's see what those x values are as just in case. So again, we're focusing on this x value here, so -3 to 2. That is the area under the curve, all right? So from -3 to 2, here we go. So go ahead and pause the video. Yep, so this was -3 to 2. Pause the video, set up the integral, and overall combining, simplifying to see what we're going to find the integral of, to calculate the area bounded by our two functions. And here we go. So here you are setting up, we're talking about from -3 to 2 of 6 minus x squared minus x, right? Because that's our f of x minus g of x, top minus bottom. So that means you're going to end up finding the integral of -3 to 2 of -x squared minus x plus 6. So that is what we're finding the integral of. Then again, if you want to continue and practice, that means here we go. We've got -x to the third divided by 3 minus x squared divided by 2 plus 6x. Again, from -3 to 2. Then again, we would substitute, right? So 2 in for x, then minus, substitute -3 for x. And that would be our area between the two curves. So now that we've talked about the setup, now let's actually go through and solve. So notice we're given our f of x, g of x, and our boundary. So here we go. Let's set it up. So from 0 to 1, right? We've got our f of x, which is x squared plus 2, minus g of x, which is x. That means we're going to find the integral, so from 0 to 1, of x squared minus x, right, subtracting x, plus 2 with respect to x. So now we'll find the integral, right? So here we've got x to the third divided by 3 minus x squared divided by 2 plus 2x from 0 to 1. So if you need to now, get your calculator or get Desmos Scientific up and substitute. So when you substitute 1 in for x, and then minus when we substitute 0 for x. So now here you should have noticed when you substitute 1, you should get 11 over 6. Minus when you substitute 0, notice it's nice because everything goes to 0. So the area is 11 over 6 square units. So here, now notice we'll do 2b, but we're not given the boundaries. So let's go ahead and let's graph. Now we're given what x squared and x cubed are. So go ahead, pause the video, and let's see if you can identify the boundaries. And so here you should have your graphs. And zoom in so that you can see. So notice how our x squared is up top. And notice here, we're focusing on this section right here. So we're focusing on from 0 to 1. We're finding the area of this section here from 0 to 1. So here we go. So again, from 0 to 1, f of x, x squared, minus g of x, x cubed. Now notice it's really kind of just straightforward as is, right? No simplifying here. It's just x squared minus x cubed. So that means here, go ahead, find the integral. And again, we're focusing on x to the third divided by 3 minus x to the fourth divided by 4. Then we're focusing on from 0 to 1. So now go ahead and substitute 1 for x. You should get 1/12. Then minus, substitute 0. Well, notice it goes to 0. So the area under the curve between those two functions is 1/12. Now we're not doing the 2c here, but here, now notice, same thing. We're going to find the area under or bounded by, between our two functions, but notice you're not given what f of x and g of x are. So not only do you have to identify the boundaries, you also have to identify what function is on top, your f of x, and what function's on the bottom. So go ahead, pause the video, graph these two. Let's see what you think. What is f of x, what's g of x, and what are the boundaries? And so here you should have noticed the x squared function is what is up top, and the x, graph of x, is what is your g of x. And the boundaries are from -2 to 1. That is the section of the area here that's bounded by our two curves from -2 to 1. So here we go. So let's go ahead and set this up. So from -2 to 1, and again, f of x was 2 minus x squared minus x. So keep going, pause the video. If you need to rearrange, get the integral. So what is the area between our two functions? And so here, if you wanted to rewrite, this is -2 to 1. So negative x squared minus x plus 2, right? So if you rearranged with respect to x. So the integral in this case is negative x to the third over 3 minus x squared divided by 2 plus 2x from -2 to 1. So then here, substitute 1 for x minus, substitute -2 in for x. You should get the area of 9 over 2, or 4.5. So the last type of problem we'll go over is, what if it's just the x-axis, right? Or y is equal to 0. So y is equal to 0 is another way of saying the x-axis. Now, keep in mind, this is going back to, oh, this is then finding the area under the curve. But now you have to consider, because this is not given to you, if it's f of x or g of x. So is it f of x? Is it above the x-axis? Or is it g of x? Is it below the x-axis? So pause the video, graph it, because then you're going to also get your boundaries. And so notice here, the graph is below the x-axis. So it is below. So that means this is the g of x. And the boundaries are from -1 to 4. So from -1 to 4, we're finding the area of this section here below. So that means here, when we go back, sorry, there we go. So again, from -1 to 4, this was, if you think about it, right? So it's 0 minus the g of x, which is x squared minus 3x minus 4. So notice we're finding the area from -1 to 4 of negative x squared plus 3x plus 4. That's what we're finding the integral of, right? Because again, notice it's like our -1 here, distributing our negative. So now go ahead, get the integral, substitute, let's see what you get. And here we go. So the integral is -x to the third divided by 3 plus 3x squared divided by 2 plus 4x from -1 to 4. So then again, you had to substitute 4 in for x, get your value, minus substitute -1 in for x, get your value. You should get the area of 125 over 6. So pause the video, try this one. So again, identify, does this function represent the f of x or g of x? What are the boundaries? And what is the area under area bounded by our two functions? So here you should have noticed from graphing that the function was below. So this is your g of x. Your boundaries you should have used are from 0 to 6. So here we go. Oops, sorry about that. So from 0 to 6, that was your g of x. So it's 0 minus x squared minus 6x. So again, the integral of from 0 to 6 of -x squared plus 6x, again with respect to x. Then you find the integral, which was -x to the third divided by 3 plus 3x squared from 0 to 6. When you substitute 6 in for x, you should get 36. Minus, when you substitute 0 for x, you get 0. The area is 36.